When you look at NVIDIA today, a multi-trillion-dollar company at the absolute center of the AI universe, it's easy to think it was all inevitable. But it wasn't, not even close. Their journey was really forged in these incredibly high-stakes, almost company-breaking decisions. So we're going to explore how a series of visionary bets didn't just build a company, they basically engineered the entire AI revolution. This quote from CEO Jensen Huang, "You have to understand this to understand NVIDIA." It's not just some nice-sounding mission statement. It is the literal operating system for how he runs the company and, honestly, how he shapes the future of tech itself. So here's the game plan. We're going to walk through the moments that really defined NVIDIA. We'll start with the problem that forced them to change in the first place, then get into the wild gamble that nearly broke them. We'll look at the unique leadership style that made it all possible, see what it's become with today's AI factories, and finally, check out the massive challenges that are still ahead. Okay, so to really get NVIDIA's strategy, you have to understand the problem they saw coming years before anyone else. The old way of making computers faster, well, it was hitting a brick wall. Simply building a better, faster graphics card just wasn't going to cut it anymore. Now, this is the core reason why. It's something called Amdahl's law. It sounds kind of academic, but the idea is super simple. Think of it this way. If a program spends half its time doing calculations and the other half just waiting for data, you could make the calculator part infinitely fast, and the whole process would only be twice as fast. You're still stuck waiting. NVIDIA realized the chip wasn't the only bottleneck anymore. The entire system, the networking, the storage, everything was the problem. And that meant you couldn't just throw more servers at a problem and expect it to get faster. The whole data center, that was the new computer. This forced NVIDIA to completely change their identity. From just a chip company to a full-on systems company, co-designing every single piece of the puzzle. So, staring down that scaling wall, NVIDIA made the decision that would define everything that came after. It was a bet so massive that Jensen Huang himself called it as close to an existential threat as they'd ever faced. They decided to create an entirely new computing platform from scratch, CUDA. And right away, this created a classic chicken and egg problem. I mean, a computing platform is totally worthless if you don't have developers making software for it, right? But developers, they are not going to waste their time on a new platform that nobody is using. They need a massive user base, an install base. Huang knew his computer history, and history shows that having a massive install base is everything. It's way more important than having the most elegant or perfect technology. I mean, think about it. The x86 architecture that powered PCs for decades. People complained about it all the time, but it dominated because everyone had one, while tons of better designs just faded away. So their solution was brilliantly simple and just terrifyingly expensive. They realized their secret weapon was already out there, in the hands of millions of gamers, their GeForce GPUs. So they made this radical choice. We're going to put CUDA on every single one of them, whether the gamers ever use it or not. In one fell swoop, they could create the world's largest install base for a brand new computing platform overnight. The cost was just staggering. Supporting CUDA on all those consumer cards was so expensive it ate up all of the company's profits. And the market? It was terrified. NVIDIA's valuation just plummeted, from around $7 billion all the way down to $1.5 billion. They were literally risking the entire company on this vision. But the bet paid off, big time. By leveraging their gaming business, they basically put a supercomputer in the hands of every researcher, every student, every tinkerer in the world. They created the fertile ground where, years later, the AI revolution would explode. As Huang says, GeForce literally built the house of NVIDIA. So, how in the world does a leader convince an entire company to make a bet that risky? Well, it all comes down to Jensen Huang's unique philosophy, which is less about giving orders and a lot more about slowly and very deliberately shaping what people believe is possible. See, instead of making some sudden, shocking announcement, Huang spends months, sometimes even years, just laying down these bricks of logic. He uses every new piece of data, every engineering update, to gradually shape the thinking of his teams, his board, even the entire industry, just one piece at a time. And the end result of this whole process is that by the time a huge, game-changing decision is officially announced, it feels completely obvious to everybody involved. He's built the logical path so clearly that the team is already there with him, basically wondering what took him so long to make it official. That's how you get total buy-in. All right, so let's jump to today and see how this all comes together. Because of those early, crazy bets, NVIDIA isn't just a chip company anymore, not even close. They are building an entirely new kind of machine, the AI factory. This is a fundamental shift in what a computer even is. It used to be all about retrieval. A computer was basically a warehouse for files we already made, but now it's about generation. These AI factories don't just store stuff, they generate new, valuable intelligence, what they call tokens, on demand. The limiting factor in this new world isn't storage space, it's pure raw computation. And trust me, the demand for that computation is only going to accelerate. Huang lays out these four scaling laws that show why. First, you've got pre-training. Bigger models plus more data equals smarter AI. Simple enough. But then comes post-training, where the AI actually generates its own data to learn from, creating this crazy feedback loop. Next is test time, which is the insane amount of compute needed for an AI to actually reason and plan things out in real time. And finally, agentic AI, where one AI can spin up whole teams of other AIs to solve complex problems. Each of these steps is an exponential leap in compute demand. So you might be thinking, what could possibly stop this exponential growth? Well, building this AI-powered future is definitely not a given. It presents some of the biggest engineering and resource challenges humanity has ever faced. There are three huge blockers. First is power. We're talking about AI factories that consume the same amount of electricity as a city. Second, the supply chain. You have to coordinate hundreds of global partners to build machines more complex than anything ever made. And third, efficiency. You're in this constant race to get more and more computation out of every single watt of energy. Huang's answer to all this? It's the same thinking from the very beginning. Extreme co-design and shaping the entire supply chain by convincing partners years in advance to make the multi-billion-dollar bets needed for the future he sees. The whole NVIDIA story really shows that world-changing innovation requires leaders who can not only see a different future, but who can make the terrifying, gut-wrenching bets needed to actually manifest it into reality. And it leaves us with this final question. What other futures are we failing to build right now, just because we lack the conviction to make those same kinds of impossible bets?